I'm gonna go over integration in Wolfram Mathematica, and there are two main functions for integration in Wolfram Mathematica. And the first one is integrate, and the next one is an integrate, just like that. The integrate returns exact answers, just like with fractions, and an integrate returns decimal approximations. Okay. Now, how can we define an integral in a symbolic form? We can also define it symbolically, right? And to define it symbolically, all we have to do is to press escape button, then int escape button again, and we get it. Just like that. And when you get that, you actually can select it with the tab button. You have a window appearing, and you can just enter whatever you need. That is, in my case, this, and it just solves it. I mostly use the command version of the integration because I do think it's easier. And let's just give it a try. Let's say we have x squared plus 2x plus 1 as our expression, and we'd like to integrate in terms of x. And it just gives us the answer. Now, when working with symbolic form, that is the int, you select it in TT, ask again, and let's say you have an expression that says cosine, let's say sine x plus cosine x, and you like to integrate in terms of x. As you can see, it's not really understanding what we wanted to do, and that is because the whole expression actually is not being integrated. That is, the dx only attaches to this part of the expression. And in order to fix that, we need this large parenthesis, which we use, and then the problem is solved. Just simple like that. Now, we can integrate, we can also have definite integrals, that is, from some bound to bound. Let's say we have x squared and like to integrate it from 0 to 10. And we just solve it and we get the area under the curve, right? You can also use variables if you want. A, B, doesn't matter, works in any case. You can use a number for 1, works as well. And you can also visualize the integrals if you say x squared, right? And we plot it from 0 to 10. And if we plot it, we get the graph. And now right now it's just a simple graph. And so what we'd like to do is to fill that space underneath it, right? And so let's just fill in axis, and that's it. Now we've seen this filling of the space beneath the graph we have, which practically represents the integral. Now you can also represent this definite integral not only in terms of the form of the function, but also as d int t and another t, and then you press ask again and you get it. Let's say we want it to go from 0, x squared, in terms of x, and it solves it normally. If you wanted to get an exact answer, you could use an integrate. Then you could use x squared as the expression, and you could integrate it from 0 to 10. And that would give you the exact answer, which is correct. Another thing you can do with integrate is that you can actually integrate in terms, have multiple integrals, right? And in a single command. Now, I don't recommend doing this because it's not really intuitive. But I'm going to show you that approach nevertheless. And that is, let's say you have an expression just like this. And the first integral, like the innermost integral, will be in relation to x, so definite integral in relation to x. An outermost integral will be in relation to y with bounds from -2 to x. And as you can see, the outermost integral will be having these boundaries, that is upper boundary and lower boundary, and will be evaluated in terms of y. And the innermost, that is after we evaluated that integral, right, we apply another integral again, but in terms of this x. And this is how we get this expression. There is a better way to do that, and I promised you to show it to you, and that is integrate. It's the same command, but instead of one integrate, you just use two integrates. That's it. It's very simple and much more clear. So you destructure it, you put the integration bounds outside for the outside integral, right? And no, it's not y, it's x. It's x. And integration boundaries for the inner integral. That is, let's copy this whole expression. And inside, we integrate from -2 to x. And as a result, we get the same answer. But in my opinion, in my honest opinion, this is much more clear, because you can actually see that this bound belongs to this integral, which is inside of this integral, right? And we can also do it with the symbolic representation, right? And with symbolic representation, we just have to type d int t. And then inside, we just have to type, we have to aim at that square right there, and we just have to type d int t again. And this is practically it. First might be y, next one might be first one might be x, next one might be y. Then you just enter your expressions, as you see. For some people that might be more intuitive, but I'm more of a programming language guy, so this seems to be more comfortable for me, more convenient. And that is practically it.